So good afternoon, ladies and gentlemen. So first of all, I appreciate very much the Professor C.T. Liu and Professor Wang. Of course, I appreciate President Wei Kuo and for inviting me to City University of Hong Kong. And so it's my great pleasure and honor to be here to have the City University distinguished lectures. So today I'll talk about development and applications of bulk metallic glasses. So first I'll introduce my background, followed by the presentations of the crystalline alloys and amorphous alloys, and nanocrystalline alloys, and superelastic alloys, and then I'll show you that the concrete data of the bulk glass alloys. So my background, I obtained doctoral thesis from Tohoku Universities in 1975. Then I worked as a research associate and associate professor and the directors of Institute for Material Research, IMR, Tohoku Universities. Then in 2006, I became the president of Tohoku Universities. And after finishing my presidency positions, I have been working at several universities of the Josai University, King's Abdulaziz University, Tenjin University, Ningbo Institute, Shanghai Jiao Tong University, and so in addition to the City University of Hong Kong. And anyway, that's the. So, as you know, that the Tohoku areas had very serious earthquakes on March 11 in 2011. So at that, I introduced very briefly the disaster situations. Anyway, in 2011, of course, Tohoku University is a very comprehensive university and covers all the areas from humanity, social science, and engineering, natural science and information science, and agriculture, and wide medical areas, including the very big university hospital. Then the total numbers of the students, 18,600, including that the foreign students of about 1,500. And that the Tohoku University has employees of 11,600, including the part-time employees. You know that on March 11th in 2011, that the Tohoku areas had the very big earthquakes with magnitude of 9.0, which is the third biggest earthquakes in the world. And anyway, that's the focus place of this big earthquakes. And the Sendai city is located. And also I think that the Sendai city is located here, which is about 380 kilometers from Tokyo. And Sendai city, and you can notice that the Fukushima Daiichi nuclear power plant, and that's the direct distance is about 90 kilometers. But now Sendai cities didn't have any pollution from the nuclear power plant, and so that's the areas marked with red colors. Was damaged by tsunami. This is the Pacific Ocean. And the main campus in Tohoku University are located in the downtown of Sendai cities, and these campuses didn't have any damages from tsunami. And for the last 1,200 years, so Tohoku areas had the 5 very big earthquakes with magnitude of over 8.0. Which generated along the boundaries between the Pacific Ocean plate and the Eurasia continental plate. Just that's anyway, that's the boundary regions. So anyway, I stop here. That's the disaster situation because we need that 1 hour or something. Anyway, I move on to that academic. That's the field. Anyway, that's as a master student, that's for 2 years, I studied the carbide precipitation reactions from martensite in carbon steels with the aim of clarifying that the possibilities of precipitations of high carbide phase between epsilon carbide and cementite carbide. So I have shown some data of the precipitations of monoclinic high carbide phases during the tempering treatment of eutectoid carbon steels. And as a doctoral student, so I studied the deformation and fracture behaviors of cementite carbide in carbon and alloy steels. So in the pearlite phase, you know that the cementite carbide surrounded by the ferrite phase. So after cold drawing of carbon steels, you can see that the slip planes inside the cementite carbide. So cementite carbide can be deformed along the, in this case, 100 plane. So on the 100 planes, slip planes, you can see the high density of dislocations, which was judged to be screw-type dislocations in carbon 1.25% carbon steels, cold rolled to 92% reduction in thickness. After annealing, we can get this kind of network-like dislocation structures at that time, so I identified the natures of dislocation characters. And also, we clarified the slip planes, deformation behaviors of cementite carbide itself by using the single cementite carbide crystals. In this case, at 500 degrees Celsius, you can see that the cementite carbide deformed along the 100, 010, and 001 and 110 planes. Anyway, that's the, I analyzed that's the direction, orientation, crystal orientations by using the focus, very fine beam Raoult pattern, Raoult X-ray patterns. Anyway, for following 1 year, I continued to study the deformation and the internal faulted structures of alloy carbide, these alloy carbide. So here I wanted to say that before 1972, I think I must confirm that Professor C.T. Liu, is it right or not? Little is known about the deformation and fracture behaviors of any compounds themselves. I think that this is believed to be the first example of the study and deformation and fracture behaviors of carbide itself. And that's at IMR, Professor Osamu Izumi's groups also didn't study the intermetallic compounds before 1972.